where there is f of x equals the series -1 to the n over 4 to the n times x minus 5 to the n converse. Notice that the center of the series is a equals 5. We're going to use the ratio test. A sub n is -1 to the n over 4 to the n times x minus 5 to the n. A sub n plus 1, we replace n with n plus 1. With the absolute values, we can ignore the factors -1 to the n and -1 to the n plus 1 only. Using the ratio test, the limits of the ratio a sub n plus 1 over a sub n, we multiply the reciprocal. Note that we ignore the factors -1 to the n and -1 to the n plus 1 already. X minus 5 to the n plus 1 is x minus 5 to the n times x minus 5. So we can simplify the expression inside the absolute value. Taking this limit, we can factor out x minus 5 over 4 in the front of the limit. But this limit n over n plus 1 is 1. So 1 times x minus 5 over 4 is x minus 5 over 4 with the absolute value. Note that we found the limit. The limit is 1 over 4 times the absolute value of x minus 5. But the ratio test said that this series converges only if the limit is less than 1. And so for the series to converge, we need 1 over 4 times the absolute value of x minus 5 to be less than 1. Solving for x, we see that x is between 1 and 9. The series converges for all of the x values in this interval. Since the absolute value of x minus 5 is less than 4, we say that the radius of conversion is r equals 4. We still need to check the endpoints. When x equals 1, replace x equals 1 into the series, we end up with the series -1 to the n over 4 to the n times -4 to the n, which can be simplified to 1 over n, which is the harmonic series, so it diverges. We then check the other endpoint. When x equals 9, replace x equals 9 into the series. We have the sum of -1 to the n over 4 to the n times 4 to the n. We simplify to the alternating harmonic series, so it converges. On the real number line with the center of the series x equals 5, we see that the series converges for all of the x value between 1 and 9, diverges when x equals 1, converges when x equals 9. And so we say that the series converges for all x in the interval 1 to 9, excluding 1, including 9, and the radius of conversion is 4, or 1 less than x less than or equals 9.